Good morning, students. So far, we have discussed about the methods of preparation of amines, and also we have discussed about the chemical properties of amines. During the last classes, we have discussed how the primary amines are reacting with different kind of species, and also we have discussed how to test the different kind of amines, that is primary, secondary, and also tertiary amines. Now, the most important topic of this chapter is the basic nature of amines. So, amines are basic, and how they are basic, why they are basic, and how their basic nature are being affected by other factors. That is a matter of discussion in today's class. Okay, so let us discuss about the basic nature of amines. Basic nature of amines. First of all, what is the base? We have different concepts of base that we have studied in the first year class. Okay, so normally base is a substance which can accept a proton equal to Bronsted, and base is substance which can donate at least one pair of electron equal to Lewis. Okay, so if you think about ammonia, see NHH. This ammonia is having a lone pair of electron here. Okay, now this ammonia can donate this lone pair of electron to the electron deficient species, and also this ammonia can accept a proton. To form module NH4 plus. So because ammonia can accept a proton and also it can donate a pair of electron. If I take NH3, suppose BF3 is an electron deficient species. This ammonia is having the lone pair of electron. Now this lone pair of electron, this nitrogen atom can donate this one. So because here this nitrogen atom can donate a pair of electron to see BF3 electron deficient, so it's a what? It's a base. What kind of base? Lewis base. Here, this ammonia can accept a proton H plus having no neutron, no electron. Now this can accept it and form a bond NH4 plus. So this also what will the base. Exactly the similar case happens in case of amine. Now, if I take amine RNH, RNH2 is what? Amine. Amine. Now, if I have a proton having no electron, so now this lone pair electron of that atom can take proton. Will you get what? N H plus. Second case, R N H. If I have B F, this pair of electron it can do this one. So like ammonia, this here the amine can donate the pair of electron plus BF3. So it's a Lewis base. It's what? Lewis base. And again, this amine can accept a proton to form the cation. So it's a what? Bronsted base. It's what? Bronsted base. So amines can behave as a Bronsted base as well as a Lewis base. Now, the strength of the base It depends upon the tendency of losing the electron pair and also the stability of the cation formed after losing the electron pair. You will see, if you consider this one, RNS2 with H plus giving value RNS3 plus. Now, whether this RNS2 will accept the proton or not, that depends upon the stability of this RNS3 plus. Okay. So, after accepting the proton, if the cation formed is becoming stable, then the amine will be interested to accept the proton to convert into a stable cation. If after accepting the proton, the cation formed is becoming unstable, then the amine will not accept the proton. Okay, so any factor which can enhance the electron releasing tendency of that atom will enhance the basic strength, or any factor which can make the cation more stable will enhance the basic strength of the amine. So the strength of the base depends upon the two factors. One is the electron releasing tendency of that atom, and other part the stability of the cation formed by accepting the proton. Clear? Now, if you take C, NH2 plus H2O, NH3 plus OH minus. So if I write K is equal to RNH3 plus into OH minus divided by RNH2 into H2O. Okay. Now K into H2O equal to RNH3 plus into OH minus divided by RNH2. And we know H2O is a pure solvent. Its concentration taken as constant. So constant K into constant I can take what? Simple as KB is equal to ionization constant. So K into H2 is equal to KB called ionization constant equal to RNH2 RNH3 plus into OH minus divided by RNH2. Okay. So this KB is called value of ionization constant of the base. More the value of KB, more will be the basic character. And the value of KB will depend upon this term. Okay. More the value of KB again. PKB equal to minus log KB equal to log 1 by KB. So more the value of KB, less the value of PKB, and more will be the basic character. So the basic strength of a base depends upon the ionization constant value KB. More the value of KB, less the value of PKB, more is the basic character. So by determining the value of this KB of different kind of amines, different kind of primary amines, secondary amines, tertiary amines, methylamine, ethylamine, okay, ammonia. So comparing the value of KB of different species, the basic strength can be compared. Okay. So in this manner, by comparing the value of Kb of different species, we can conclude some factors. Number one, alkyl amines, or simply we can write amines. Amines are more basic than ammonia. If you compare the Kb values of ammonia and amines, then the amines Kb value will be more than ammonia. That means the amines are more basic than ammonia. Number two, in aliphatic amines, the basic strength is tertiary, more than secondary, more than primary. When present in gaseous phase or in non-aqueous medium. Number three, basic character of methyl amines in aqueous medium is secondary, then primary, then tertiary. Basic character of ethyl amines in aqueous or polar medium is tertiary, secondary, then tertiary, then primary. Okay. Number 5, aniline, that is what? Aromatic amine is less basic, than ammonia and aliphatic amines. So these are the facts obtained when you compare the Kb value of the amines. If you compare the experimental Kb value of ammonia, methyl amines, ethyl amines, primary, secondary, tertiary, and also aromatic amines, if you compare the values, experimental values, these things we can apply. Now we will discuss these facts theoretically. How the experimental values support the theoretical aspects of these facts that we will discuss. First of all, amines are more basic than ammonia. This one. What is the fact? You see, I have already told you the basic strength of the base depends upon the tendency to lose the electron from the atom, and also the stability of the cation formed by accepting the proton. Now see, in case of ammonia, we have NH3, we have the lone pair of electron only in the net atom that can donate to the electron deficient species, and also this can accept the proton to form NH4 plus ion. Now if I go for RNH2, RNH2, this R is an amine, this R is a plus I group. So it will release electron to the net atom, so that the electron density on this net atom will increase. Because the electron density on the net atom will increase, so nitrogen can donate the electrons easily. Okay, number one. Number two, when this is a combined with proton, we will get value R N H plus. Now because this is R is what group? Again plus I group. The plus I group will release the electron to the net atom, so that the positive charge on this net atom will be dispersed. So the positive charge on this species can be dispersed by the help of the plus I groups, and dispersion of the positive charge makes the cation more stable. So here, due to the plus I nature of the alkyl group, the electron density on the net atom increases. Number one. Number two, the positive charge on the net atom is getting dispersed with the help of the plus I group, and more the dispersal of the positive charge, more it has stability. So both the factors are working here because of the plus I group. The stability of the cation is increasing, the electron density is also increasing. That's why amines are more basic than ammonia. Clear? Number two. In aliphatic amines, the basic strength is tertiary more than secondary more than primary. When present in gaseous phase or non-aqueous medium. If the medium is non-aqueous, simply what happens? R N H, okay, R N H. Clear? Now see, in this amine, tertiary amine, this Rg plus I, this Rg plus I, this Rg plus I, plus I, plus I, plus I, plus I, also positive. So if we see now here, in case of tertiary amine, three alkyl groups are there, and all the three alkyl groups are electron releasing plus I in nature. Okay, so in the gaseous phase, when we see three alkyl groups are present, they are increasing the electron density on the net atom more and more. And again, the positive charge on the net atom will be dispersed more and more due to three alkyl groups. So obviously, the stability of the cation will increase, and also the electron density on the net atom will be more. Hence, the net atom can easily donate the electrons. So the basic character will be more. Okay, and same things will happen here. But if there are only two alkyl groups, so this effect, plus effect, will be less here. Here again more or less. So what happened? Tertiary amines are more reactive, more basic, then secondary, then primary. So in gaseous phase or in non-aqueous medium, the basic character of aliphatic amines is tertiary more than secondary, more than primary, due to what? Due to the plus I nature of the alkyl groups. Clear? This over. Now, number 3, the basic nature of methylamine in aqueous medium is secondary more than primary, more than tertiary. So what happens when we are taking the ammonia in an aqueous medium or a polar medium? Okay, so here the basic character is governed by 3 things. One is the hydration effect, or called solvation effect. Number 2 steric hindrance. Number 3 process. Okay, so when you take the methylamine in aqueous medium, then the basic character is governed by 3 factors. Okay, in gaseous phase it is governed by only the plus I nature of the alkyl group, but here not only the plus I group but also the hydrogen effect, steric hindrance are also working in addition to plus I group. First of all, what is your hydrogen effect or solvation effect? See, when we are putting the amine in aqueous medium, the amine accept the proton and become the positive ion. Now, the hydrogen atom present in the amine, that is attached to hydrogen atom, again can form hydrogen bond with the water molecules. So after accepting the proton, the hydrogen atom present in the nitrogen atom of the amine can form hydrogen bond with the oxygen of the water. Okay, and by the way, the energy is released called what? Hydration energy or solvation energy. And this hydrogen energy stabilizes the cation, and hence the basic character increases. Okay, so if I consider, see, if I take a tertiary amine R N R R, okay, if I take a tertiary amine H plus, and again what? R N R R H plus. Now this H can form what? Iron bond. Okay. Now if I take a secondary amine R N H, okay, H plus R N H plus. Now this H can form what? Iron bond. Okay. Now if I have primary amine RNH2 H plus RN H plus. Now this has O H O H O H. Now we compare. In case of primary amine, already 2 hand atoms were there, and when it undergo protonation, I am getting what your RNH3 plus. Now 3 hydrogen atoms are present here, which are forming 3 hydrogen bonds with 3 water molecules. So more hydrogen bonding, more hydrogen energy, more stable is the cation. So more basic is the amine. So I can say what the tertiary amines here are expected to be more basic. Clear? Now concept of the primary amine, concept of the tertiary amine are 3 and proton, only one hydrogen bond. So hydrogen or solution is very less, hydrogen energy less, so strength is less, so basic character is also less. In case of what secondary amine, see one H is there, protonation getting 2 hydrogen atoms, so 2 hydrogen bonds with 2 water molecules. So the hydrogen is somewhat more than the tertiary or less than the primary. Okay, so accordingly the basic strength is what less as compared to primary and more as compared to tertiary. So this is one way that the hydrogen effect to determining the basic character. Okay, so according to hydrogen effect, the tertiary amine should be more basic. Sorry, primary amine should be more basic, and tertiary amine should be less basic. Clear? Now, number two, the steric hindrance. What is steric hindrance? See, when I am taking R, N, R. Now see, when I have the tertiary amine here, now this nitrogen atom will take up the proton. Now the proton will come and attack to here, but here see we have already what alkyl groups are there. The molecular alkyl groups are there. Now the molecular alkyl groups already present attack the nitrogen atom will not allow the proton easily to attach this nitrogen. That means the proton cannot be attached easily if more alkyl groups are present in the nitrogen atom. So because tertiary amines are having 3 alkyl groups, so they are not allowing the proton easily to attach. And this effect is called the steric hindrance. So in this way, if you consider tertiary amines, they are less basic. Okay, but the primary amine, if you consider there is no molecular groups, so they are more basic. Okay. Number 3, plus effect. General plus effect, more the plus group, more is the electron density on the atom, so more will be the basic character. So on this basis, we can say tertiary amines are more basic and primary amines are less basic. Okay. Now see, if you compare now, R, N, R, N, H, R, N, H. Okay. So here the basic strength is what? The basic strength in methyl CH3 N CH3 is more basic than CH3 N more basic than C3 N C3 reasons. First of all, tertiary amine containing methyl group are less basic in aqueous medium. Why is so? Because in here three molecular groups are there, which is causing more and more steric hindrance, and hence it is not allowing the proton to adhere to the atom. Number one. Number two, because of three alkyl groups, so it can form only one hand bond with water, so less hydrogen, so less stability of the cation. That's why the tertiary amine is less basic. Okay. Now primary amine here, primary amine, no steric hindrance, there is no steric hindrance, and also the hydrogen effective is much more. That's why its basic character is more than the tertiary. But when you compare these two, secondary and the primary, okay, near about the hydrogen effective, though here is less as compared to this one, okay, but the plus effective in case of secondary will be somewhat more as compared to the primary. That's why the secondary amines are more basic, then primary, then promiscular of tertiary. Okay. But if I take ethyl groups, if I take ethyl one, then what happened? C2H5 N C2H5 H will be more basic, then C2H5 N C2H5 C2H5 tertiary. Then what your primary. In case of ethyl group, when ethyl groups are present in aqueous medium, then secondary is more basic, then tertiary, then primary, and this is because of what more plus sign is nothing else. Okay, so always remember in gaseous phase or in non-aqueous medium, the tertiary amines are more basic, then secondary, then primary. In aqueous medium, when we have methyl group, secondary more basic, then primary, then tertiary. When we have ethyl group, the secondary more basic, then tertiary, then primary. Okay. Now next come to your basic nature of aromatic amines, that your aniline. Now basic nature of aromatic amine, that is aniline. See, if I take aniline, NHS, this phenyl group is what? Minus I in nature. Because the phenyl group is minus I in nature, this will create a decrease of electron density on snap atom. So the basic character will be what? Less. So aniline is less basic than ammonia and also aliphatic amines. In case of aliphatic amines, RNS2 is what? Plus sign, increasing the electron density on the net atom. Okay. But in case of aromatic amine aniline, phenyl group is what? Minus sign. Okay, decreasing the electron density on the net atom. That's why the aniline is what? Less basic than aliphatic amines and also less basic than ammonia. Number one. Number two, you see, if I will take aniline, see, NH now this low, it is the low number of electron with the help of which the amines can behave as a base. Now here this low number of electron is in conjugation with this pi system of this ring. So what happens, you see, this will come to this place and this comes to this. You don't have to go resonance. Okay, so we will get what? double bond NH, okay, plus minus, okay. Again what? This will come this plus one, this come this one. We will get what? This one, double bond NH2 plus this come this one, this come this one. We will get what? We will get what? Double bond NH2 plus again this come this come. We will get what? Single bond NH2. So what happens now? The aniline undergo resonance. Now many contributing structures are there, and you see in the contributing structures we are having the plus charge on the magnet atom. So some of the contributing structures are having plus charge on the magnet atom. That means it becomes electron deficient. So how can you give electron? Okay. So because the lone pair of electron of magnet atom here in conjugation with the pi system of ring, so that is creating the positive charge on magnet atom, and hence the electron releasing tendency of the magnet atom decreases. That's why aniline is a weaker base. It is less basic than ammonia and also less basic than aliphatic amines. And again, this basic character of this aniline depends upon the presence of plus I or minus I group. Presence of plus I group, as usual, plus I group increases the electron density on the atom, hence the basic character increases. But presence of minus I group, electron withdrawing group, decreases the electron density on the atom of the aniline. That's why the basic atom decreases. However, irrespective of the group, whether plus I or minus I, if the group is present at the ortho position, then the basic character becomes less. This is called what? Ortho effect. So whether plus I or minus I, if present at the ortho position, the basic character becomes less. Number one. Number two, electron withdrawing groups decrease the basic character. Electron releasing groups increase the basic character. But this effect is more at a para position. Okay, the decreasing tendency of basic character or increasing tendency, both are working more at the para position. Okay, let us see. If I take suppose aniline okay, and if I take hardware para-methyl para position, and if I take meta, I will take what one? Ortho. So the basic character of ortho substituted product is always less whether it is plus I or minus I. So which will be least basic? This one least basic. Okay. Now when we have plus I group, the basic character increases. Now forget about the ortho. Okay. So when we have the plus I group, the basic character increases. So which will have less? L. Okay. Now, presence of plus I group increases the basic atom, and this increases much more at the para position. So para will have highest one. So immediately we have what meta. Okay. So para position plus I group more basic. Okay. Then simply in the least basic midway meta is there, and irrespective of the plus I minus I group, the ortho separate product is the least basic. So we have ortho methyl adenine, then metamethyl, then paramethyl. Finally, if I take minus I group, suppose nitro. Now minus I group. Okay. See, presence of minus I group decreases the basic atom. So which will have the highest basic atom? Aniline. Okay. Now the effect is the more to para. So para will be least basic. Then your meta will be more. Then aniline will be more. Now which is the least basic? The ortho substrate products are always less basic, whether plus or minus I. So what do you write? Ortho nitro with the least basic, then para nitro, then what do you? Meta nitro, then what do? Aniline in the most basic. Hello. Okay. So presence of minus I group decreases, and this decrease more in para. Okay. So in midway we have meta, but this is your associated case. Ortho products are always less basic. This is due to what do? Due to what do? Ortho effect. Okay. So this is about how the basic nature of aliphatic as well as aromatic amines. Next class one also we discuss the different kind of questions based on the amine chapter. Okay.